Let's take a look at handling input with SFML. And for this, I'm actually going to set it up that if I press a button, let's say W and S, then it will change that text we added in the previous video. So we can make a decision here. I think I'm going to put all of my input handling before I run the simulation. And then after the simulation is run, I'll update all of the graphics. So with SFML, we can, there's a few methods that we can use to check which buttons are being pressed. So you'll have to decide which buttons do what in your game. But then we can do this. So if SF keyboard is key pressed, and then we give it another SF keyboard key W, I'd like to change this text that says score 0. I'm going to change it to say W pressed or whatever. To do that, we need to make use of the standard string streams. So I'm just going to call this my OS. Then I'm going to load these characters in there. W pressed. And now this thing gives us a handle for this string, so we can access it like this. I'm going to tell my score text to set the string to os.string here. We can do the same thing for the S key, and that should do it. So also the order in which you have these if statements kind of matter now, because if we press W and S at the same time, it's going to take the one that executed last. So I'm going to press W. There we go. I'll press S, and then I'll press both of them. You see that? The S takes precedence, and that's because it evaluates last. We can sort of get around that somewhat if we just add this else if in here. But then the same issue stands, right? The W now takes precedence. But that's very specific to this case because we're modifying the same object here. But there we go. We now have input handling. These keys are going to be used to control the paddle. And I guess this was pretty short and easy. We can actually make the paddle. So for this, it's going to be the same deal. We've been making these things this whole time. So I'll need a B2 body definition for my paddle body def. This is a B2 default body definition. The only difference now is that instead of setting it to a static or a dynamic type, we're actually going to make use of the kinematic body type. Then we can set up the initial position. So the position of this thing, I'll place this physics body, let's see here, at 1 meter to the right. And then I want to put this in the middle of my screen. So 6. That should be fine because of our proportions or our dimensions here. 6 is going to be the middle of the screen. That should do it for my body definition, the type and the position. So then I need a B2 body ID. Call this my paddle ID. B2 create body. It wants a world ID, so I'll pass in the world ID and then the reference to my paddle body definition. So there we go. We have our body ID. Now I need the shape configuration as well as the geometry. So let's start with the B2 shape def. Paddle shape def, going to be a default shape def. And that's kind of it. The next thing is a B2 polygon for the geometry. Paddle geo. And then we'll say B2 make box. This is where we specify the size. So for the X, I'll make it 1 meter sort of wide in this case. And then as for the height, we can make this 2 meters high. That should do it. And then we have a B2 shape ID for my paddle shape ID. Say B2 create polygon shape. I'll give it the paddle ID. Then it needs the shape definition. So paddle shape def and then the paddle geo. And that should kind of do it. Let's make the graphic. So an SF rectangle shape. I'll call this just the paddle. And now I need to give it the size here. So up here I said that it's going to be 1 meter. So this half height, if we times 2 here, then it gives us 1 meter. So that means that it's pixels per meter. And the half, or rather the half width is 1 meter. And then the half height says it's 1 meter here. So that means it's going to be 2 meters. So we can have 2 times the pixels per meter. I'd like to center the origin. So set the origin. And in this case, we can actually take the paddle, get size, divide by 2. So that'll give me the center of that rectangle. Let's do paddle.set position. I'll do B2 to SFML. Then I'll say B2 body, get position of my paddle ID. And now, if everything worked out, we should be able to draw this. So I'm going to draw it here. This is the player controlled paddle, so it's kind of separate from all the other things. If I run this, my paddle should show up. There it is. Now it looks kind of small here. It might be better to make it a little longer. So let's put the half height at 1.5, and then this will turn into 3. If we run this, and there we go, we have a longer paddle. Now we need to move this around. So W and S is used to move this around. So now instead of setting the text, we're going to set up some vector value to control the movement of this thing. So outside of these if statements, the default state of this paddle is to not move. So we can have a B2 vec, call this the linear, we can call it the velocity, and initialize it to 0 and 0. And then we'll do some processing. But after this, we'll do B2 body, set linear velocity on our paddle ID. And the value is going to be this B2 vec that we just created. Now, so to set up this linear velocity to move our paddle in an upwards direction, we'll say linear velocity dot y equals -1. And if we hit S, then it'll set this to 1, to +1. And if we don't press any of these buttons, this value will be used. So the 0, 0. This only moves our Box2D entity around, but we still need to take care of updating the graphic. So we've already done that with the ball. So my paddle graphic here, I can set the position. To get this position, I'll make use of my conversion method. It's going to be B2 body get position for this paddle ID. So let's see here. I'm going to run this. And there we go. It's moving, but it's very slow. So we can add in some constant value up here somewhere. Maybe here at the top where we have these constants. So const expression float paddle speed. And I'll make this move at 5 units. Then I need to take this paddle speed and use it here. And since I'm doing this with 1, I can actually just substitute paddle speed in there. And then this should do the trick. Look at that. Let's make the ball move towards our paddle instead. And that's going to be simple. We've already created this ball. And then somewhere in here, I have a linear velocity setup. So it's not going to move on the Y anymore, but it is going to move on the X. So if I run this now, the ball should collide with my paddle. And there we go. It's going off screen here. So next up, we'll need to create an AI controlled paddle. And that should just match the position of the ball to intercept it.